Guillermo Galván, ladies and gentlemen.
Thank you very much, Sharon. Good morning, ladies and gentlemen. I come from Tenerife, obviously, and I'm an engineer that works at ITER. It has been presented to you already. What I'm going to talk to you about is that experience we have there in our terrains about bioclimatics and the bioclimatics dwellings we have built. But let's go back in history a little bit. That's why it is called Back to Basics. Initially, architecture took advantage of the environment where the houses were placed. That was a necessity to protect the inhabitant from the harsh environment and also to take advantage when it was beneficious for the inhabitants. We're talking about people that went into caves to protect them from rain, from sun, and everything, but also to take advantage of the local resources, okay? So it was very important, the climate where the building was going to be placed, the location, and also the culture. And the envelope of the house depended a lot on what were the social conventions in that time for people, how people lived and things like that. I will give you a brief example of local architecture in the Canary Islands to see how it influences the construction. For example, I put you there that question, whether you use high ceilings. Obviously, in people like the Canary Islands, where the heat is an important matter to be protected from, you use high ceilings so the heat goes up, and where you have the living areas, you have some fresher air. Or, for example, in places like here, where you have a lot of rain, you have double-pitched roofs. That's just an example for you to see how in traditional architecture those things were taken into account in a sometimes unconscious way. This is some houses from the Canary Islands. We have lots of microclimates in Tenerife, for example. So you'll see different architecture in the south or in the north, where you can have a temperature difference of maybe from 5 to 10 degrees. But usually the traditional architecture has a courtyard in the middle, and all the rooms go into that courtyard. It usually has lots of plants and some water elements, which now we know allows us to get a fresher air inside the house. That was made unconscious, as I was telling you. Now the science and all the techniques gives us some insight of how that was made. All the rooms of the house led to that courtyard, and you have all the protections from the sun, which you do not need here, but there is not for protecting us from the rain, but for the sun. So those are some traditional architectures. As you see, all the patios follow the same structure. So you are able to enjoy the sun in milder weather, but when it's summer, you have fresher rooms. So the problem was that architecture evolved from that to build an envelope where you were not only protected, but isolated from the outside. That's a brief example. You can go to Tenerife, to the south, where the touristic places are, and you may be in a hotel. That hotel may be the same for Tenerife, or if you go to Java or wherever. You know, it could be anywhere in the world, because it doesn't take into account the place where it is being built. Bioclimatics is applying the science and the knowledge we have now to that traditional notions of how a house should be built depending on the place where you were building it, and tries to measure. That's the important thing of bioclimatics, trying to measure that performance. So those are the basic guidelines for bioclimatic architecture. You cannot take a building and place it anywhere in the world. It depends on the climate, it depends on the direction of the wind, it depends on the latitude where you are placing it, on many things. Before the design, you have to be respectful and using local materials. It's not sustainable to build a house and bring materials from 3,000, 10,000 kilometers away. Being functional, it depends on the use you're giving to the house, and obviously the minimum energy consumption. We will see that afterwards, but it's really important to the promotion of renewable energies. I work in the wind energy department, so for me it's basic. But there is the aspect also of energy saving. The cleanest energy is the one that you are not wasting. So it's not only important to trying to increase the penetration of renewables in any electrical network. It is also important to reduce the demand. And that is one of the things bioclimatics do. The basic design aspects you follow when dealing with bioclimatics is to have the comfort zone inside the house. The most important one is the thermal comfort, obviously. If you are in a cold weather, you need to increase the solar gains to take advantage of the sun, to take advantage of the mass of the materials to keep the inside warm. Or if you come from a hotter place, like I do, you have to try to cool down the inside of the house. There are a few processes, we'll see them briefly now. Those are several schemes where you can see how you can collect the sun energy. Basically, you have three aspects. You have to collect it, you have to get it transmitted to all the house, and you have to prevent it from going out of the house. You make that with glass surfaces orientated to the south if you are in our latitude. And then once you have the sun, that heat inside, you distribute it, and with mass walls or ceilings or floors, you prevent it from leaving. That's the basic thing. Here you have 4 different examples of a house and where the mass walls are located to transmit the heat to the rest of the house. You have also a few techniques for cooling the envelope, the dwelling. You have many of them there. You have to protect yourself from the sun. That's sometimes you have to go both ways. You have to, depending on the season, and we'll see an example afterwards. But basically, you are protected from the sun. You try that the heat does not enter the house by painting it white, by using certain materials. You may be in that envelope where you cool the outside so the inside stays fresh. You can humidify the air currents. You can have increased the ventilation inside the house. Here you have those seasonal decisions you make for a house. For example, in the winter, the alternative is to capture the heat and keep it in the house. But on the summer, you may need to keep it cool. And that would be a few things to make it. There are 2 diagrams which are pretty important for bioclimatics. We'll see the next one, but in all guys, what you try to do is in the outside. What's the comfort zone in the outside, places? You have that man over there, that's the comfort zone for him, but then the rest of the areas, most of them, can get into the comfort zone by use of vegetation, shadow, the materials you use on the floor, on the terrain. You have in the cities where the temperature rises 1 or 2 degrees in contrast to rural places. And that's because the thermal mass you have on the concrete and on the floors is too big, so it's storing heat during the day, and then even at night it still keeps warm. This is the one which is important for us, which is Givonis diagram. Here you have that place where the comfort zone inside the house. You have on the axis you have the temperature, and then all those curved lines you have upwards are the relative humidity. So here you have a location, you have a house, and you measure temperatures during the year. For every month, you measure the lowest temperature and the highest temperature, and also the humidity. If you're placed in the comfort zone, you don't need to do anything to change the conditions inside the house. But then if you go out, there are some things you can do. Obviously, in that part of the diagram, it is really cold, and you may need heating, traditional heating. On the other extreme, you may need air conditioning. But on the rest of them, with ventilation, with internal gains, which means people living in the house, when you are making food in the kitchen, the light bulbs and everything gives us a bit more heat, so it gets into the comfort zone. One really important thing about bioclimatics, it only can be measured when you are living in a house. It's not something you can check in an empty space. It really needs that the inhabitants gets in a dialogue with the house, gets to know the house and interact with it. And finally, when all the bioclimatic design regarding materials and envelope are not enough, the proper thing or the best thing would be to get the energy you need to heat or to cool the house with renewable energies. Right now, in photovoltaics, wind energy is a bit more complicated, but photovoltaics have evolved a lot, and they have a lot of integration possibilities in a house. I'm not telling you more about ITER. I have already told you a bit. So the thing is, the Cabildo de Tenerife, like 15 years ago, decided he wanted to experiment in bioclimatics to see how it could affect the island of Tenerife. So in collaboration with the local College of Architects and the International Union of Architects, we made a tender, an international tender, where nearly 400 projects were submitted from different team architects from the world. They were given some guidelines. They had to design family houses. They were going to be built in Tenerife, in a ravine in the south of the island, with specific meteorological conditions, climatic conditions that we gave them. And the objective was that they had no energy consumption at all from the local grid, okay? Only they had to take advantage of bioclimatic design to reduce the energy consumption, and the extra energy they needed had to be generated with wind turbines or with PV panels, which were to be integrated in the house. That was basically the requirements they had. The thing was, we wanted to have a laboratory of those 25 completely different solutions from different teams of architects. They were given all the information. We have a technical committee, which I was in that technical committee where we were asked for consultations from all the teams before they presented the projects on local conditions, on things they needed. Some of them were experts in bioclimatics, some others weren't, but they learned in the process. And the idea was to build that 25 complex houses, complex with the houses. Well, those are some. We had 25 selected. Finally, only 24 were built because one of the team of architects were no longer available when the results were set. And but the winning teams are from Spain, Italy, and Belgium. I will show you the pics of the houses. They just presented 2 panels with the house, and all the 25 selected will have that house built. That was an important thing also. It was not an experience in design and just for paper. They were meant to be built. That was the important thing. In fact, each house, the works for the building of each house was to be directed by each of the architects that had won. Those are the designs, the initial designs they sent us. I just placed them here so you can see how the result went. And this is the final development, which is being built and is being used. I will explain to you later. Those are all the houses, as you see, are in ITER terrains. That was also a handicap because when people come to stay in those houses, they are they're in an industrial state with PV plants, with wind plants. That gives us some problems regarding noises, for example, for the wind. Well, even though noise is the main issue, when you're in a windy place, the wind already introduces a lot of noise. So you are only aware of that wind problem in specific wind speeds, in low wind speeds. So this is the development. And these are the houses, that one. This is the winner. It was from a Spain team of architects. And as you can see, there's a wall surrounding it. It's called La Heria because in Lanzarote, the architect was inspired by Lanzarote. They have a very good wine there, and they have vineyards, and they have to protect them from the wind because the wind tears them down. So they semi-bury the vineyards in the volcanic ash, and then they surround it with a stone wall to be protected. He inspired himself in that, so the house is protected from the northeast wind, which we have 95% of the time, and it's also semi-buried, as you can see here. At the end, for that local weather we have there, many solutions are the same, but they were approached differently regarding the architects that made them. You have the living exterior, you have two patios, which are protected from the wind. That's the most important thing, from the wind and the sun. You may see all those small ceilings, all those protections to make all places able to be enjoyed. That's the courtyard you have in the back. Just wanted to give you some slides. This is the second one. The house, when you see it by itself, it may look a little bit odd if you compare it with the rest of the houses. But the thing is that Natasha and Sergio wanted, they designed a whole development. This house is meant to be built in a whole development with houses like that. And it would look really different. At the end of the conference, I'm giving you the results of this house in that Givonis diagram. Bioclimatically is one of the houses that's best designed of the whole development. It's really well protected, and you can see the size of the walls to prevent the heat from getting in. As I was telling you, these houses right now are being used by tourists and scientific experts that come to Tenerife and everything. This is the star, the third prize. There was a tie for the third prize of the contest. You see there how the integration of photovoltaics is made. All the rooms of the house are connected through a courtyard, external courtyard. You will see it in a couple of pictures later, like a traditional Canarian house. So they modern teams of architects with lots of tools. They changed the size and the form of the houses, but they follow the same guidelines. As you see, the courtyard in the middle. And this is also the third prize from a Belgian team. And I just, they also have, here you have some greenery in the middle and everything. And another important thing I didn't told you before, not only heating and cooling, is the use of light. Depending on the size of the windows, on the orientation of the windows, it is really important. It is really nice to live in a place where you are taking advantage of direct sunlight. You are not wasting energy in artificial light where you don't need it, basically, and mainly in a place like this. You have long areas facing south, as I told you, to collect the heat. These are all pictures of the different houses that were selected and constructed. Natural lighting, as I was telling you. As you can see, with just a few guidelines we gave them, they came up with really different solutions. That's the beauty of the development. For example, there you have that wall, that thermal mass. You have all the living areas, not the the night areas. You have that. You have them in that cube over here, that white cube. So you get the collection of heat from the facade facing south, and that wall prevents it from getting into the night areas. This is the same house. As you see, all the protection elements, and you interact with them. Obviously, if you, depending on the season or depending on the needs you have, you can open them. You get cross ventilation if you open windows on the extremes of the house to have some breeze inside. to cool it. I guess the presentation will be available for you so you can see them and you can check them on the website, or so I'll just go through with them to get to the. Well, you have also here, as you see, it's also semi-buried, and to protect it from the heat, you have vegetation on top of them. A couple of houses decided to put shells, seashells, on top of the houses, also to isolate it from the sun. And you can also check in the few slides the integration, which was really important for us, the integration of PV panels, that sometimes people are against them because they are too noticeable. They decided sometimes to hide them or to use them as architectural elements. And that was really, really interesting. I have a couple of slides at the end of the presentation. Also some water elements to cool the environment. Here you have completely separated. This is the night area, and this is the day area. Here you have it, just the difference. And let me just, these are really fresh and cool bedrooms. They are buried in the ground. They have high ceilings for the heat to leave the room, and only those small windows which are not placed in direct sun, so you have good conditions at night. This development is being inhabited by tourists right now. I have to be honest with you, and we didn't think it would have a high demand, but luckily we were wrong. And there is a sector, there are tourists that look for something like that doesn't want to go to the south to big developments. They want to go to a nice place, to a place which is conscious with environment. The houses are really nice, we have to admit that. And they're placed in a nice spot because you are close to everything and you are in a really calm place, okay? Not in the middle of touristic, noisy, busy areas. And the thing, initially we wanted them to be inhabited only by experts in bioclimatics or energy, but there were too many. There were not so many experts wanting to come to Tenerife. And the reason we decided to place them in the touristic sector, as they're under houses for investigation. That's a specific topic when you are exploiting a touristic development. And we needed it because we needed them to be used. If they were not used, we would have no results. And the most important thing for results too, as bioclimatic houses are living places, they had to be adaptable. We are planning on, after the first 2 years, we're reaching 2-3 years of use, to make improvements in the houses, in the houses that needed them, to make the living conditions better. That is the last one. As you can see, the panels, how they are used as constructive elements. So let's get to the monitoring phase. All the houses have lots of sensors inside for humidity, for wind speeds, and for temperature. And they are monitored real time. We are storing maximum, minimums, and average data for each minute in each houses. And the nice thing is that the inhabitants can see in real time on their TVs how the house is performing. The house comes with a set of instructions. We give them to the people that come there. Some of them use them, some of them don't. But they can check if it's too hot inside, what they can do to improve the conditions in there. That is always online, not only for us as technicians, and which have to analyze the data, but also for each of the inhabitants. There you have, for example, that's El Caminito, that's the second prize, where all the sensors are located. that's a real capture of our data acquisition system. For example, in that last table you have the wind analysis. We have a very strong and constant wind from the northeast, with the biggest average in the summer, like you see there on August, for example, 7.4 meters per second or 7.85 in July. And inside the house you still have that breeze. It's important to have it to cool it. And you can see that it's bigger in summer, which is a great thing for the design of the house, because it's when it gets heated harshly. Here you have Givonis diagram for that house. And all the small lines are the maximum and minimum temperatures inside the house from January to December. And as you can see, all of them fall into that comfort zone. If they were out of it, some solutions would have to be made in some houses. Some of the 24 houses, some of them are not all there. Some perform great in winter, but not so great in summer. And the next phase we are dealing with is to improve the design of the houses to make them better. And as I was telling you, besides being used by tourists, we have lots of guests, of tourists, not staying at the houses, but staying in the south or in Puerto de la Cruz, and lots of schools. And really important thing is the dissemination of the results, that people are aware that things like that can be made, that even in your own house you can make some improvements. You can reduce your energy bill by introducing bioclimatic design. And the whole development can be visited at certain times to have to respect the people's privacy. The people stay in their privacy, and ITER's aim in general is to be an open institute, which anyone can visit. Some tourists do, the type of tourists that then stay in the houses. Some others don't, which is a shame. They come to Tenerife, but they leave it without knowing there's something like that there. But that is the aim we have, to disseminate the results. And regarding bioclimatics, to make people aware that things can be done even in your own home. Thank you very much. That's all.
Thank you very much, Guillermo. Thank you, Guillermo. Thank you very much. The extraordinary thing about these houses, for anybody who hasn't been to Tenerife, is that they are located in quite extreme conditions. Having lived in Tenerife for a number of years and tried to keep my house either cool or warm when the weather changes, it's very difficult if you don't have the right adaptations. And these bioclimatic houses are extraordinary, because you come out from arid sunshine, from wind blowing you away in the face. I mean, we are on a wind farm after all. And the conditions inside the houses are remarkable. It's quite a project, and we're very pleased you could come here today and talk about it, Guillermo. And I'd like to know if anybody has any questions on the bioclimatic houses for Guillermo from the floor. Thank you. If you wouldn't mind just saying your name and where you're from. Thank you.
Hello.
Hi.
First of all, thank you very much for the lovely presentation and seeing all those fantastic projects, particularly from the inside. I found those houses very appealing and attractive, which is not a normal thing. It's not usual in bioclimatic architecture to have that feeling of wanting to be there. Very often they are machine-like. My name is Simon Medio. I teach at the School of Architecture at the University of Lincoln. And one of the questions I wanted to pose here was, were they, apart from clearly these houses had to be energy efficient, that was the goal. And what about materials? Were there restrictions in regards to locally sourced materials?
They were advised to use local materials. Some architects didn't. But when it came to construction, we sat with them. We gave them information on, you saw most of the houses have that yellow stone, which is Tosca, which is local stone available there. And some of them had used some other, some marble, some other things. And we urged them to change them. And to use that, not only that, but volcanic rock, which is what we have available there. So finally the development, even though in some of the projects they use some other materials, we use local materials for all of them. That was the aim. Even if the architects decided to use some other thing, we sat with them and studied the possibilities to really adapt them, because if you are bringing material from the outside, it's no point in a bioclimatic house.
I've seen that thermal mass is used a lot.
Yes.
A lot of buildings use that. And I suppose this has been a very precious experience, because you have all 25 buildings and you can really see how each strategy
That's the thing.
performs, coupled with the human aspect, I think, which is also important, of the pleasure of being in a house, and also the aesthetics, because you show the second prize there, and with the performance of that house. And it would be interesting to see the relationship between, you know, the
aesthetics.
not necessarily the prize winners, but, you know, the relationship between the building form and aesthetics and its performance.
Finally, well, from our experience, even though there are really beautiful houses which bioclimatically are not specifically well designed, you don't have, because the thing is, as Sharon was telling you, you have that harsh weather in summer, but then when it gets to winter, it's not cold like it is in London. But if you have that house only designed to prevent you from the sun and the heat, you will be cold in winter. So you had to manage both aspects. From the tourists that are living there, some of them choose the house because of the looks, but finally you end up, people that end up in houses which are not the most good looking, they have better living conditions. It's not an overall rule, but it happens. Like I showed you the second prize Caminito, when we saw it being built, it was like, it's a weird house, too many columns, too many walls, big walls. But then the living conditions and the inside of the house, once it was decorated and everything, it is really nice. But I agree with you that sometimes you have to be innovative to integrate the bioclimatic design with an appealing house. That's fine.
Thank you.
You're welcome.
Hello, my name is Gordon Jackson. My company is Alive Water UK. We work in the health and well-being sector of water. And we talk a lot about plants and water features in central homes. And what kind of water do they have running through these systems?
Well, they have, some of the houses have some solutions to collect rainwater, but we have a local reservoir of water in ITER. That's what we use. They were also encouraged to use regarding the bathroom or the I don't know now the word, but the kitchen, the plumbing and everything, to use water efficient ones. Even though I never mentioned it, but water was another thing. It wasn't only the energy aspect, but also as in the island we have problems with water, even though Tenerife has some water galleries which allows us to be a bit better than the eastern islands. But they were required to use water-efficient devices. But the water we consume comes from a reservoir we have there, because we are pretty far away from settlements.
So we have a system that goes in homes that does the whole home or the whole building, what creates negative ions. And negative ions is very healthy for the people, for the plants, and for the environment. And it's just a question to bring health and well-being, because you're saying they have a lot of visitors. So you have people that stay in these buildings, they can leave with feeling much better, more alive, more healthy, and it's just a sector that we're very interested in and bringing to Tenerife.
That's a good idea. Thanks.
Can I just mention, Guillermo, I believe there's also a system with one of the houses, if I remember correctly, with a tejado húmedo. So they actually use plants on the roof and the water drawn in by the plants as part of the temperature.
Yes, and they have, there were a couple of slides, you can check them later, better, where they have some rain chimneys where you collect the rainwater to not for consumption obviously, but for use in the bathroom and also to cool the environment, the air.
We have another question here, please.
Could I just ask whether you utilize heat pumps at all within the design? Do you know, say, cool the house and warm your swimming pool, or
No, well,
Storage of heat.
there is no swimming pool, but the only thing we use is solar collectors to heat in the water, but no heat pumps. They were allowed to use whatever they wanted, the architects, but well, you have to take one thing into account. I don't know the expense that it would be, but one of the other requirements of the houses was that they could not exceed a certain cost. So they were, some of them used PV panels when they were not so cheap as they are now, but they don't have that many installations, because one of the things was they had to be houses to be constructed for an average person. So they had to get into a certain cost. I think it was 15 millions of pesetas in that time, which is, let's see, approximately 90,000 euros or something like that. They had to be built for under that, but they don't use heat pumps.
Okay, thank you. Have you considered using the geothermal gradient beneath the house, you know, almost making them like caves and half underground, and you know, there's normally about 35 degrees per kilometre depth?
Yes, they use in fact, they use the ground to cool instead of to use the heat. I have a colleague here, Nemesio, which works in geothermal energy, and to see if the resource is good in the place. If to use a heat pump in the location when we are placed would be suitable and profitable, but that may be taken into account in that phase I was telling you about, where the houses can be adapted once we know the performance they are having. That may be a line of work. You're welcome.
Any more questions from the floor? Thank you. Thank you. Would you mind just letting us know your name and where you come from?
My name is Becky Ladley and I'm a social media consultant. I was just wondering, is it something special about the climate in Tenerife, because you said it's one of the best ones in Europe and the most hours of sunlight, that makes these houses so suitable for there, or is it possible to do that in countries like England where it's raining most of the time?
No, the thing is this, you can export some of the results to places with similar climate characteristics. That was a problem in architecture years ago. You had a beautiful building in Norway, and you decided to replicate it in Andalusia in the south of Spain, and that was energetically a nightmare. The user did not notice anything, but the cost of energy to have a building which was built for a cold climate in a warm one, that's awful. The most important thing is that the house is designed for a specific place. They could not be, if you see a house you like and you want to build it here, probably you'll spend a lot of money in heating. So it has to be placed in a specific
Thank you very much. Guillermo, thank you very much indeed for your
You're welcome.
presentation. Thank you.